This is a WattBox. If you haven't heard of it, it's a surge protector with an IP address. If you look online on Shodan, there's a couple hundred WattBoxes just connected directly to the internet. If you log in through the web UI, which has default credentials, WattBox, then you will see a pretty standard looking like IoT device. So at this point, if you've ever messed around with these kind of things, you might think, well, maybe we can start injecting, try to get command injection inside of a ping field or some kind of input field. But rather than just blindly dropping in payloads and trying to get code execution, we're going to go the more thorough route and pull the firmware. And I want to detail this because this is often one of the most significant barriers to entry. So the first thing to do here is just go to the vendor website. If we log in, there's no clear list of firmware to be downloaded. But if you open up the front end, go into Chrome DevTools, and just search around for calls to some kind of firmware endpoint, we do see that there's this firmware.js that is loaded in the front end. If we browse through it, we see it mentions a v1 firmware endpoint that isn't actually called, but it is mentioned. So we can then go and grab a known good API call, copy it as curl, and this is what it looks like. It's calling the MyDetails endpoint, but we can swap that out for the v1 firmware endpoint. And once we start massaging the request a bit, so we're giving it everything it's expecting, we see it gives us an S3 link to download the firmware. So we're on the right track. When we download that firmware, we see there's a compressed kernel image when we bin walk it. If we decompress it, we see that there's a decompressed CPIO archive. If we extract it, we see an offline version of the same file system that is running on this device right now. Now, at this point, what I will point out is many IoT devices bake all of their most significant functionality, typically into a single monolithic binary. So in this case, following that very simple heuristic, I just looked for the biggest file on the file system, and there's a 55 meg file called runtime. It's a MIPS executable. If we look in Ghidra for references to the system function, we will see, I don't know, 20 or so functions that all seem to invoke system. And there's one in particular I looked at called land setHostname, which seems to be exactly what it is, which is something that takes untrusted input from an attacker, interpolates it directly into a string, and passes it to the system function, which spawns a shell. That's a clear path to command execution.